Welcome back, Twitch viewers. Here comes our Cosmology segment, but first, we'd like to thank our Twitch followers, our BitChute followers, our new subscribers over on YouTube. Thanks very much for subscribing over on YouTube. If you haven't done so, please press subscribe. And please share our content on your social media as the algorithms hate us. Today's Cosmology segment should be interesting. It's got various stories here, and let's go. How about X-ray binary Maxi J1820 plus 070? It's a system consisting of a white dwarf having material siphoned off of it by a thing like a neutron star or some sort of a massive radio source. And this is a phys.org article in their astronomy and space section. And what they're noticing is a proportional relationship between the X-ray output and the rest of the electromagnetic frequency band. So the electromagnetic spectrum, folks, these objects have a proportional relationship between their X-ray output and things like their radio output or their infrared spectral output. And what we're talking about here is several outbursts and rebrightenings, which showcases an evolution trend similar to the outer black hole low-mass X-ray binaries, which is most likely a result of temperature change in the outer disk during the outbursts. So the point is, folks, there is a relationship between the toroidal fields and the poloidal fields of these objects. And they're looking at phase transitions here. The pseudo-equivalent width of emission lines exhibit anti-correlations with the X-ray flux, which could be due to the increased suppression by the optical continuum at around the X-ray peak. The full width at half maximums of hydrogen and helium lines appear to stabilize at the 19.4 and 21.8 angstrom wavelength. So according to this paper, it corresponds to the line-forming region at a radius of 1.7 and 1.3 solar radii within the disk. So that's sort of a sweet spot within the toroid. There is a disk of ionized gas and dust between these objects, and there's a Lagrangian point 1 associated with these outbursts and so forth. Perhaps read this article. And there's a link to the paper as well here. There is not a link to the paper. Anyway, this one is about Maxi J1820 plus 070. We won't worry about looking at that one. And let's talk about neutron star skins. Here's an article on SciTech Daily. This isn't really a test of neutron star skins. This is a test of the properties of the nucleus of lead atoms in the laboratory. So the neutrons are believed to reside in a shell around a spherical clump of protons in the nucleus of a lead atom. And this has some sort of an effect on the belief of what neutron stars are made of. We just continue to call neutron stars massive radio sources, as their radio and X-ray and other spectral outputs are something that we can actually measure. So perhaps read this one. Does it really tell us anything about a neutron star? I'm not so sure about that, but it certainly does tell us something about lead nuclei. Now, this is the Crab pulsar, and I just wanted to bring up this image to cite a quick little thing here. One, this is the poloidal field of the pulsar. So you see that jet coming out there? That's coming out of the pole. And the poloidal field is probably shaped like a cone like this, not to be confused with the toroidal field, which is this donut-shaped region. And again, there is a proportional relationship between the spectral output from material in this field versus material in this field. And the Crab pulsar is a great place to illustrate this. Continuing on, and by the way, folks, these objects do not behave just as vacuums, they also behave as fountains. It's a combination of vacuuming things up and fountaining things out. And black holes, the objects, the massive radio sources referred to as black holes, do the same thing. There's a proportional relationship between the spectral output from the torus and the spectral output from the poloidal fields. And what you're looking at here, by the way, is this is X-ray, and I think this is infrared spectrum here. But this is certainly X-ray. That's certainly from the Chandra X-ray telescope there. Next, talking about muons, and let me preface this section with a quote from the article. A muon is about 200 times as massive as its cousin, the electron. They occur naturally when cosmic rays strike Earth's atmosphere. Particle accelerators at Fermilab can produce them in large numbers. Like electrons, muons act as if they have a tiny internal magnet. In a strong magnetic field, the direction of the muon's magnet precesses or wobbles, much like the axis of a spinning top. All spinning objects in the universe that we know of precess, folks. The strength of the internal magnet determines the rate that the muon precesses in an external magnetic field that is described by a number known as the G factor. This number can be calculated with ultra-high precision. And the calculation of this G factor is flying in the face of the standard model of physics. So we've covered this actually, I think, 2 other times before on the Daily Space Weather videos in our Cosmology segment. And this is part of where the rubber hits the road between laboratory physics and what we see happening in space. This is very important, as are a lot of different features of physics. So perhaps read this article, or maybe just pause the video since we're scrolling the article here. And the point is, folks, we have not yet arrived at a unified theory of physics, which is part of our mission at smAsho.com. If you haven't read our mission, head to smAsho.com/forum/mission, and you can read all about it. The number 1 item on the list is assist, study, and report on the ongoing unified theory of physics. The ongoing formation of a unified theory of physics, folks. It's kind of important. Let's move on to today's astronomy photo of the day. It's Polaris. And if you want to know how to find Polaris in the sky, let me just show you the Big Dipper. So here's the Big Dipper. I'm just going to draw it like this. And these 2 stars right here, at the end of the cup of the Big Dipper, they point toward Polaris. So let me just draw that again. So there's the Big Dipper. These 2 stars right here form a line, and that points directly at Polaris, Earth's celestial pole. And of course, there are other celestial pole stars during Earth's precessional axial tilt wobble cycle, such as Vega and Deneb, and some other stars. But in any case, today's astronomy photo is Polaris and the surrounding dust. If you want to check out the daily astronomy photos, it's apod.nasa.gov. And by the way, Polaris is a Cepheid variable, and Cepheid variables are part of the reason why I don't have an astronomy degree. And without going further into that, let's pick a random number between 1 and 1031. Today's random number is 802, which coincides with some object here at the Neil Gorell Swift Observatory. What might 802 be? Well, I'm wondering. Are you? We won't keep you in suspense anymore. 802 is SAX J1819.3-2525, a low-mass X-ray binary / massive radio source believed to be a black hole. And check it out. We've got some cyclicity here. We've got some voids in the X-ray outputs from SAX J1819.3-2525, a catchy name. Let's check it out on Simbad. Let's see what we can see. And it looks like it's in a very busy part of space. We'll take a look at this in some other wavelengths. So this is the DSS2, which is the optical band. Let's take a look at it in ultraviolet on the Galix. Does it show up on the Galix? No, it doesn't. How about on the Chandra? And there it is in X-ray. You can see it's a bit of an oblong X-ray source here. Not perfectly symmetrical. How about the XMM Newton? How about the Swift Bat X-ray flux? Nope. How about on Pan stars? And actually a great view there, a pretty high resolution view of it on Pan-STARRS. That's today's random object. Some object which I will never memorize the name of. And to quote Einstein, never memorize something you can look up at SAXJ 1819.3-2525. That's today's Cosmology segment, and we'll have to say goodbye to Twitch once again. Bye, Twitch. We'll bring you back once again for the meteorology segment.